Hello class, welcome to lesson 2-3, which is all about solving multi-step equations. By the end of this lesson, you should be able to solve equations involving more than one operation, as well as solve equations involving consecutive integers. Now you might be wondering, what is a consecutive integer? A consecutive integer are integers in counting order. So consecutive integers are integers in counting order. So for example, if I ask for 3 consecutive integers, if I say 5, 6, 7, those would be consecutive because I'm not skipping any numbers. Now if I said 2, 5, 8, those are all integers and they're in least to greatest order, but they are not next to each other on the number line, so they are not consecutive integers. It means that they're right next to each other on the number line. We will deal with consecutive integers. We will deal with consecutive even integers. So that means even numbers that are next to each other. So for example, 2, 4, 6. Consecutive odds would be 1, 3, 5, 7, so on, so forth. Okay? So consecutive means right next to each other. But first, let's start with some multi-step equations. This first one, we have 12 equals negative 7f minus 9. We want to solve for f. Remember that instead of doing order of operations, or PEMDAS, we do the order of operations backwards, or SADMEP. You'll hear it both ways. Alright, so as always, we are going to start by teeing it up. If we want f by itself and we want to move stuff that are either subtraction and addition first, if we want f by itself, we're going to have to move this minus 9. How do we undo minus 9? We add 9. What we do to one side, we have to do to the other. So now we have 12 plus 9 on the left side, or 21, equals negative 7f. Again, our variable is not by itself, so we are going to tee it up. How do we get f by itself? We have negative 7f. I didn't say an operation in there, so multiplication is implied. That means to undo multiplication, we are going to do its opposite, which is division. And to get f by itself, we're going to divide by negative 7 on both sides. So now I'm left with f on the right side, and 21 divided by negative 7. Let's see, positive divided by a negative is a negative, and 21 divided by 7 is 3. So we know negative 3f must be our answer. We can always plug it in to check. So is 12 equal to negative 7? We plug in a negative 3 minus 9. We have negative 7 times negative 3, that's a positive 21, minus 9. 21 minus 9 is 12. So we know that negative 3 must be our answer. Alright, let's take a look at this one. I'm just going to pull it down a little bit so it's easier to differentiate. Now, we want to solve for a. Again, we're going to do our order of operations backwards. Start by teeing it up. If we want to get a by itself, the first thing we have to move is the 2. Here we have a positive 2. How do we undo a positive number? We take it away. So we're going to subtract 2 from both sides. Negative 3 minus 2, that gives me a negative 5, equals a over 11. Again, our variable is not by itself yet, so we're not done. How do I undo a over 11, or a divided by 11? Remember, this fraction bar is the same as division. So to undo division, we do multiplication. So instead of dividing by 11, we are going to multiply both sides by 11. We are left with a on the right side, and negative 5 times positive 11. Negative times positive is negative. 5 times 11 is 55. So we're left with negative 55 equals a. We can test that out. Is negative 3 equal to 2 plus, then we have negative 55 divided by 11. Negative 55 divided by 11 gives me a negative 5. 2 plus a negative 5 is negative 3. So I know my answer checks out. Why don't you go ahead and try this first one on your own, see how you do. Hopefully you ended up with v equals negative 2. If not, be sure to ask for some help or go back and look through your work to see where you maybe accidentally multiplied instead of divided and things like that. Try this next one. Hopefully here you told me that j equals 19. Again, if that's not what you got, either ask myself or a friend. Go back, watch the last example again. Go back, check your work. Okay? Let's look at example 2 together. We have Susan had a $10 coupon for the purchase of any item. She bought a coat that was on sale for half its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? Write an equation for the problem, then solve the equation. Okay? So we know that Susan had a $10 coupon for the purchase of any item. So that means we get to take $10 off whatever the price was. So if we're taking away $10, we know we're going to subtract 10 somewhere. She bought a coat that was on sale for half its original price. So half, I know I'm going to do 1/2 times, do we know what the original price is? No, that's what we're trying to solve for. So let's use a variable. Let's use p to represent price. So if I do 1/2 times the original price and then minus 10, that should represent the sale and the coupon. And then after using the coupon, Susan paid $125 for the coat before taxes. Okay, so that means $125. There's our equation. Now we want to solve for this equation. So as always, we are going to do our order of operations backwards. That means instead of subtracting 10 on the left-hand side, we are going to add 10 to both sides. Now we're left with 1/2 p equals 135. Again, our variable is not alone yet, so we're going to keep working. 1/2 p equals 135. So 1/2 times p. So in order to undo multiplication, we must divide, right? Dividing by 1/2 is the same as multiplying by 2. Remember, dividing fractions is the same as multiplying by the reciprocal. So what I'm going to do, I'm going to divide both sides by 1/2, but that's really the same as multiplying by 2. So if I do that, now I'm left with p on its own on the left-hand side. And now I have 135 times 2, which is 270. And if I'm unsure if I did that right, we can always plug it back in. So 1/2 of 270 minus 10 should equal 125. 1/2 of 270 is 135. 135 minus 10 is 125. So I know the original price of the jacket was, so I would say the original price, didn't leave myself enough room to write, the original price is 270. Okay? Go ahead and try to figure out this next one on your own. Hopefully you discovered that the answer was negative 13. If that is not what you got, be sure to ask for some help. Okay, so just like we talked about earlier, what a consecutive integer or consecutive even or consecutive odd integer is, here are some phrases that you're going to hear in your homework in this column. You're going to hear even integers, followed by the next even integer, odd integer, followed by the next odd integer. This should say odd. There's a typo there. And consecutive integers are just numbers in counting order. The part that you're really going to want to focus on is when you're looking at consecutive integers. We represent our first number with n because we don't know what our first number is. Our next number would be n plus 1. Our next number would be n plus 2. Let's think about that. If we started with 1, the next number as we count is 2, right? So we'd say 1 plus 1. That's 2, okay, that's right. And we have 1 plus 2. That's 3. So our numbers would be 1, 2, and 3. So hopefully that makes sense, but if not, we are still going to work with this. I'm going to do an example and see if I can help you guys out with what these are. Just a hint, I love these problems. I think they're fun. So let's make sure you know how to do them. Let's find 3 consecutive integers with a sum of negative 36. Okay, so 3 consecutive integers. 3 consecutive. If we look back at that table, it's represented by n plus 1, and n plus 2. Had I asked for 3 consecutive even integers, you would have used n plus 2, n plus 4. Same with odd, because that's going to end up skipping a number if I start with 2, because we're dealing with even numbers. So 2, then we'd have 2 plus 2, which is 4, and then 2 plus 4, 6. So our numbers would be 2, 4, and 6. Okay, but here we are dealing with just consecutive integers with a sum of negative 36. So what I'm going to do, if it is a sum, that means I'm going to add these 3 numbers up, right? So we have our first number plus our second number plus our third number, right? So this is our first, this is our second, this is our third number, and their sum is negative 36. Okay, so if I look at this, let's combine some like terms. We have 1, 2, 3 n's. So I say 3n plus, and then we have 1 plus 2. So that's 3 equals negative 36. Now, this just looks like every other problem that we've been doing today. We want to solve for n. And once we solve for n, once we get an n equals, we're going to have our first number, right? Because our first number is represented by n. Okay, so if we want 3n by itself, doing order of operations backwards, I'm going to start with addition and subtraction. It means I'm going to subtract 3 from both sides. I now have 3n equals negative 36 minus 3 brings me up to a negative 39, brings me down to a negative 39. Next, in order to get n by itself, I have to, instead of multiply there, I'm going to divide both sides by 3. I'm left with n on the left-hand side. And on the right-hand side, I have a negative divided by a positive. It's going to bring me up to a negative number. And 39 divided by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So it's a negative 13. That means that if we go back, just remember negative 13, negative 13. Our first number is negative 13. Now we have a negative 13 plus 1, negative 13 plus 2. That means our 3 numbers are negative 13. What's negative 13 plus 1? Negative 12. And negative 13 plus 2 is negative 11. If we add these 3 numbers together, we should get a sum of negative 36. Okay? So negative 13 plus negative 12, that's going to be negative 25, plus a negative 11, that's negative 36. It checks out. So negative 13, negative 12, and negative 11 are the three consecutive integers with a sum of negative 36. Oops, wrong way. This is the last example for you to try on your own. Good luck. Hopefully you ended up with 26, 28, and 30. If not, be sure to ask for some help. I'd be more than happy to help. If you have questions on anything I covered in this video, be sure to ask tomorrow in class, email me. Just make sure you get your questions answered. I hope you have a great night.